In this video, we're looking at how to use Python to make Voronoi polygons. So Voronoi polygons are used to take a map and divide up regions of the map. So for example, let's say you have multiple McDonald's locations. You're looking at where to add another franchisee, and you need to know then how much of the territory is divided to each of the McDonald's locations. So where is the customer base for each of the different locations if you have multiple ones? Or you could look at it in terms of, okay, here's the hamburger joints in town, and how do we divvy up the customer base if the customers view it all as equal, right? So you're, as a customer, I'm more likely to go to the McDonald's that's near my house instead of the McDonald's on the other side of town. So if you want to do Voronoi polygons in Python, go to drstephpowers.github.io/mgmt-in-python. So here you'll see a link to the different Python worksheets, and we are working today through the one called Voronoi polygons. So you'll click here where it says Voronoi polygons. It'll take you to the GitHub site. And once you are in here, there should be a little icon here called Open in Collab. So click on that. It will open in Google Drive. So if we just click here, in order to work through this worksheet, what you'll need to do is, one, log into your own Google account. So where it says sign in here, you'll want to sign into your own Google Drive, and then copy to your drive. This allows you to add, delete, change the code. It becomes yours to do with as you wish. So you will need to sign in if you want to run it, and you will need to copy to the drive if you want to amend it. I'm logged in on another web browser here, so I'm just going to switch over. And what we're going to do is we're going to build some Voronoi polygons for the McDonald's locations in Calgary, Alberta. So you're going to need to start off by importing pandas and NumPy. This allows us to do math, and this allows us to convert our data into tables and change their formatting. The next thing we're going to need to do is we need the longitude and latitude of the different McDonald's locations. So if you have, for example, Google Maps open, you can see here I have searched in Google Maps for all the Calgary McDonald's. I need to collect the longitude and latitude for these different locations. I can right-click on one of these locations. If I'm on a computer, I just right-click, and you can see the longitude and latitude appear here. So we would simply just click on it, and then we can put it into our code. So we'd start off by pasting it in. And since we want to create essentially a table of them, take each of your locations, put it in parentheses, and then you will put a comma, and then you'll add your next one. And so what you can see in the line of code below is I've already added all of them in for Calgary. So I simply went to and I clicked on each location, right-click, collect those coordinates, and then paste them in. And so that's what this is here, is these are all the different locations. Each location is put into parentheses with a comma in between. So I'm just going to remove this one here, and I'm going to run this. So I've given it a name. I'm just calling it data frame df. We code in Python, we call it lots of things df. Just simply means a data frame. We're creating a table. So we're going to then convert that information into a data frame, and we're using pandas to do that. So that's the pd.dataframe, and it's going to take the information from df, and it's going to create two columns. We'll call it lat for latitude and long for longitude. And so if I run this here, I can then just call df, and you can see that it's turned it into a table of information. So we can see here all the different Calgary locations of McDonald's. Notice in Python, the first one starts with a 0 instead of a 1. In the numbering system in Python, instead of starting your counting at 1, it starts at 0. Now our information is now in a table form. Alternatively, you could import it from an Excel spreadsheet. So to import it from an Excel spreadsheet, you're going to need to link your Python worksheet that you have to your Google Drive. And so the command that you have here from google.collab import drive, when I do that, it simply asks, can it connect to my Google Drive? And I would say connect. And then I just have to give it access to my Google Drive. You choose, right? If you have multiple Google Drives, you would give it access to whichever one that you are doing. So you just have to give it permission. Then what you can do is you can actually just call an Excel spreadsheet that you've dumped somewhere in your Google Drive. So here I have in a folder in my Google Drive, I have an Excel spreadsheet I have just dragged and dropped in. And you can see here it is the McDonald's data. Now, when I dumped the McDonald's data in, it had the parentheses around it. And so I need to remove those as I convert it into my table. So if your data, when you dump it in, doesn't have these parentheses, then I'll show you how you can amend the code to deal with that. But all I would do is just drag and drop an Excel file in here and then know where it is in my drive. And then that means that I can then use pd.readExcel. And here's how I would get to it. So you're going to start with /content/drive/my drive, and then whatever your folder names. And so I have a BA handbook, and I have chapter 9 as a folder, and then the file is inside. My data has no headers. There's nothing on the top that gives it names to columns, so that's why the header equals none. And then I'm reading into Excel. So I can run this here, and I can port it in. If I do that this way, and I look at this one, so here's my table here. Notice it's one column of information. It has the parentheses in it. I need to separate them out. I need to separate longitude and latitude to 2 separate columns, and I need to get rid of those parentheses. To do that, I can take my information, my data frame DF, that's what you see right here, and I have column 0, so I'm going to put hard brackets DF, hard bracket 0 to say this is the column I'm manipulating. And what I want to do is strip out the parentheses. So I am going to have it convert to a string, strip out the parentheses on one side, strip out the parentheses on the other, and then split the information by the column. So then what it's going to do is it's going to take the first bit of information, and it's going to be the latitude, that's the 51s that you see here, and then I'm going to take the second bit of information, that's this X, and then the placement of the hard bracket 1 tells you that it's the second place because we start counting at 0, and it's going to turn that into longitude. So when I run this, and then I now call my table of information, notice now it has 2 additional columns here, latitude and longitude, that it's separated out. So you can import your information in either way. So if you are not connecting and you are just pasting it in, you can do it this way. You don't have to convert it, split it. It'll auto go in to this format here. Or you can do it the other way, in which case I'm importing it from my Google Drive. I have to tell it where it's located, that it's an Excel spreadsheet, that it has no headers. And then I have to do a little bit of a conversion by stripping out the parentheses if they're there and splitting it. If you don't have any parentheses, then you can just cut out this portion here and just do the string split, and then run the code like that. Okay. All right, so now we have our data. We have 2 columns. So the first thing we want to do is we want to plot that. We want to take these locations and we want to put them on a map. So what we're going to do is we're going to use a package called Folium. Okay, and we're going to convert that data that's latitudes and longitudes into a type that is a float. So when it comes to the code that you see here, once you've imported your table of information with latitudes and longitudes, you really don't have to change any of the rest of this code. You just have to run it. So then we're going to create a map, a Folium map, and we specify where it's going to be centralized. So we tell it where to kind of zoom in on the global map, and then how much to zoom. So if you leave the code as is, it's going to take your data and find that average of the latitudes and longitudes, and that will be the center. And then you can specify how zoomed in or out it is. So if you want more zoom, then bigger number in your zoom start. And if you want to be more zoomed out, then lower number. And because it's an interactive map, you can zoom in and out afterwards. It's simply so that you don't have to constantly zoom. Then what this is going to do is it's going to go through our table. So it's going to iterate through the rows, and it is going to add markers that go with each of your latitude and longitude. With each row of your database, it's going to add and mark those locations. So again, you don't have to do anything to this code. You just simply run it. And then we output with our M, our chart. So what you see here, oops, just accidentally zoomed in and out. The little blue dots are those Calgary McDonald's locations, and you can zoom in and out. So I simply had started it with a zoom level of 10, but you can zoom in more afterwards. You can zoom out afterwards as well. So we've created our graph, and we have put in the locations of the Calgary McDonald's on it. Now what we want to do is create some Voronoi polygons. So Voronoi polygons will take, I'm just going to go back to this here and zoom in a bit. The way the Voronoi polygons work is that it will take two locations. Ooh. Here's two locations, one here, and it's going to create a line that's halfway in between. In other words, if we have these two McDonald's locations, then everybody north of this line that I'm going to add will go to this north one here, and everybody south will go to the south one. And then we do that divide between every single set of dots. So we need to break between this one here and this one here, so a line there. And then between this one and this one, we add a line here. So it starts to create polygons. Okay. So let's then look at how we do that. We are going to use a package called Spatial from Skippy, and you are importing the Voronoi and the Voronoi plot 2D. So we simply run this to import our packages. And then what we're going to do is we're going to have it create the Voronoi from our data. So we're specifying that our data has longitude and latitude, and it's going to take those values, those coordinates, and it's going to find those Voronoi polygons. So again, if you enter your coordinates into that table at the very beginning, you don't have to amend any of this code, you simply run it. Then we want to plot the Voronoi polygons. So we're going to import the package for plotting, which is matplotlib.pyplot. We often simplify it, just call it PLT to make life easier. So then what we do is we call Voronoi plot 2D. Okay, that's going to have the information for the polygons, and then we just simply want it to plot. So we want to show the plot. So again, you don't have to change any of this code. You simply run it. And what it creates here are the Voronoi polygons. So here are our blue dots representing our Calgary McDonald's. And the lines in between, as I said, are halfway in between each location to show the separation of your client base. Which ones go to which McDonald's? Now, it's not very helpful in this form, though, because you can't see the map. And so what we want to do is take this information and put it on that map that we had created before. So other forms of Voronoi polygons, applets that people have created over time get you to this point, but that's not as helpful as if we can put it on top of a map and see where these dividers really occur. So to do that, we are going to need to take these black lines that you see here, and we need the coordinates that go with them. Okay. To do that, we are going to need a package called shapely.geometry, and particularly we have polygons. We're also going to import a package called GeoPandas, and we'll call it GPD. So GeoPandas is what we're using to take our coordinate data. So we have that geographical data, And so we're going to then get the coordinates for each of these parts of the polygon. And then we're also going to have it determine the polygon itself. So that's what the two pieces are. So let's run and import this package. And then so first thing we need to do is we need to have it define the polygons. So we're going to just call that Voronoi Polygons. It's going to take that information that we created here, right? So we had Vor, and it's going to take this and these shapes that it's created, and it's going to say, okay, let's recognize that that's a polygon, and we need to look at what is the portions that are here. Okay, so you're going to run the code just as is. Just hit run. You don't have to change it at all. And then the other thing is we need it to be turned into coordinates. And so we're going to use this geodata frame to say, okay, let's take our polygons, our Voronoi polygons, its geometry, and we'll use a map. So this is just referencing a map. And so you can leave that again as is to run your code. And so if I run that and output it, what you see here is a table where it says polygon, and it is giving me the coordinates for the different pieces of that shape. So we're going to take that coordinates and we're going to overlay it on a map. So again, really notice that all these pieces here, you didn't have to amend any of the code. All you needed was that starting point where you imported your data, either by pasting it in or by calling in that spreadsheet. Once you have a table where you have a column of latitude and a column of longitude, then everything else is just running the code as set to get your polygons. So we ran this first set to plot our locations. Find those dots. We created a process to create the polygons themselves. And now we're simply going to overlay it onto a map. So we're going to use that same Folium package that you already installed. And we're going to have the maps, again, locate itself at the average. So that's this first line, location equals. And it's going to have a zoom start of 10. You can pick a different one. So you don't need to change the tile type. This is simply to specify that we're looking at a map. You can change it to different types if you want it to be a map that instead of showing roads, shows, if you want to show like mountains and ranges that way. Sorry, the type of map just escaped me. But you can change the type of map, but you don't really need to. A basic layout of cities and roads is sufficient. And then we have the same code as before where we iterate through the rows to mark the McDonald's locations. That part is the same. The part we have added here is this last line. So we are going to use Folium, and we are going to take the data that we had before. This is our GDF_Voronoi. So it's a column of polygons with their coordinates. And we are going to use GeoJSON, and we are going to add it to our map. And so by running this, and then we call our map, what we have created, I'll just zoom out a little bit so you can see, is we have created our polygons. So what this is showing here is that everything in this region essentially belongs to this McDonald's. Everything outside here belongs to this McDonald's. Everything in here belongs to this McDonald's. So we can divide up the territory and see which customer base is where. And what you can then start to see is that, for example, this is a huge polygon. So that's a lot of territory. If there were people here, and right now I think it's just farmland, but if there were people here, you would say, okay, my next location where I add a franchisee is going to be here, because this is a huge territory all the way to drive to this McDonald's. You could put another one here without harming the other McDonald's locations. Whereas you can see here with our smaller polygons, well, what's the density of the people who live of the area. Is there lots of people who live here? Because this area is going to this one McDonald's, this one's going to another. So you can see there's a pretty tight grouping here of McDonald's all located next to each other, rather than say here, which would then give you all of this territory here as well. So we use the Voronoi polygons to help us figure out where another potential location is, how close we are to the competition, how we're dividing up the customer base. And you can do all this simply by creating a table of longitude and latitudes and then running the rest of the code to create the process for you.